We are now in the hardware settings tab in the settings menu. This is the second tab as you move over, and we're going to begin with depth range. In this video, we'll focus on depth range, and then the next video, we'll go over samples, and then the video after that, we'll go over the odometer. So for the depth range, what that actually is, it means how long will the GPR collect data after it puts out a pulse each time, right? How long after it puts out the pulse will it collect record any reflections that are coming back? The default, and if I use this button down here, this refresh button, it'll bring defaults back to the entire menu. The default is 80 nanoseconds, okay? 80 nanoseconds in travel time. What this means is that it's not really a depth, it's actually time, but it's depth if you know how fast your wave is moving, then you can multiply the speed versus this amount of time in order to get your depth, right? It would be speed multiplied by time divided by 2 because it's a round trip. And so the way you would do that to calculate this depth range, or what's appropriate, is by doing a little simple multiplication. All right. So here's an example. All right, let's see if this works. So so it's set now to 80 nanoseconds in two-way travel time. Let's say you figure out that your wave is moving at 10 centimeters. Okay, so this is nanoseconds, right? Your wave is moving at 10 centimeters per nanosecond. How deep will you be able to see under these conditions, right? With this 80 nanoseconds, which is the default. Well, what you would do is you would divide, or rather, you'd multiply 80 nanoseconds by 10 centimeters, right? Which would equal 800 centimeters or 8 meters, right? In total travel distance. So in order to convert that to how deep can you go, you'd have to divide that by 2, right? Which would equal 400 centimeters deep, because it has to go down 400 and has to come back up 400, right? It's two-way travel time. So it's 400 centimeters. So what does that mean? That means that with a wave that's moving at 10 centimeters per nanosecond, that you have a window open for 80 nanoseconds, it's able to see 4 meters deep, okay? That's the answer. So let's say that you go with this default. You don't want to screw around with it. You don't want to get concerned. I'm going to go with the default, and it's going to let me see 4 meters. Here's the problem. What if you're looking for a sewer pipe that's 6 meters down? Okay. What if you're looking for a sewer pipe that's 6 meters down? What will you have to change this number to in order to see a pipe that's 6 meters down? Well, let's go over it. Clear everything? Clear all points. Okay. So we'll start back over. So if you want to see 6 meters down and it's moving at 10 centimeters per nanosecond, then you'd have to go at least 120, right? So 120 nanoseconds, right? Multiplied by 10 centimeters per nanosecond equals 12 meters. Now, again, you have to divide that by 2, right? So 12 meters divided by 2, because it's 6 meters down, 6 meters back, right, equals 6 meters. So you'd have to go at least 120 nanoseconds in order, right, at least 120 nanoseconds in order to see it. But this would be pushing it. And so what I would do is I would go even higher on, right? I would probably go, if it lets me do this, I would probably go to 150 nanoseconds in this circumstance. So it'll let me see a little bit deeper, maybe 7 or 8 meters down. So I know that I'm not just cutting it off right when my target is. But that's what this is. Okay, that's how you would do this. In order to find out what the speed is, you'd have to go into the system, run over a known utility or pipe, and then do a hyperbola fit on it. You can see how to do that in another video.